I'm Ishmala Sushit, working as an associate professor at KIT, Kalana Karnanidhi Institute of Technology. I would like to give a lecture on fundamentals and link layer. Fundamentals of networks. Computer network connects two or more autonomous computers. The computers can be geographically located anywhere. When we consider a network, the network in small geographical area, that is room, building or campus, is called local area network. The network in a city, it is called the metropolitan network, that is MAN. The network spread geographically, that is across a globe or a country. It is called as wide area network. The advantages of networks: resource sharing, information sharing, communication, remote computing, distributed processing, that is grid computing. The resource sharing, we have hardware and software sharing. In hardware, it is between the computing resources, disk, printers. In software, it is the application software. The information sharing, the files and databases can be accessible from anywhere. The search capability, it is done through World Wide Web. Communication, it is email, message broadcast. And remote computing, it is a computer to which a user does not have physical access, but which he or she can manipulate via some kind of network. Distributed processing, it is a computer network in which computer resources are shared with every other computers in a single system. Network topology. The network topology defines the way in which computers, printers and other devices are connected. A network topology describes the layout of the wire and devices as well as the paths used by data transmissions. There are 5 topologies: bus topology, ring topology, star topology, extended star topology, mesh topology. Bus topology is referred to as a linear bus. All the devices on a bus topology are connected by one single cable. Star and tree topology. The star topology is a commonly used architecture in Ethernet LANs. When installed, the star topology resembles spokes in a bicycle wheel. Larger networks use the extended star topology and it is called tree topology. When used with network devices that filter frames or packets like bridges, switches and routers, this topology significantly reduces the traffic on the wires by sending packets only to the wires of the destination host. The diagram shows the tree topology and the star topology. Ring topology. In ring we are having 2 types: single ring, dual ring. A frame travels around the ring, stopping at each node. If a node wants to transmit data, it adds the data as well as the destination address to the frame. The frame then continues around the ring until it finds the destination node, which takes the data out of the frame. The single ring, all the devices on the network share a single cable. The dual ring topology, it allows data to be sent in both directions. Mesh topology. It connects all devices, that is nodes, to each other for redundancy and fault tolerance. It is used in WANs, that is wide area networks, to connect the local area networks and for mission critical networks like those used by banks and financial institutions. Implementing the mesh topology is expensive and difficult. Network components: physical media, interconnecting devices, computers, networking software, applications. Networking media can be defined simply as the means by which signals are sent from one computer to another. This can be sent either by cable or wireless means. The signals are nothing but the datas. The networking devices are hub, switches, routers, wireless access points, modems, etc. The applications of networks are email, searchable data, e-commerce, news groups, internet telephony, video conferencing, chat groups, instant messengers, internet radio. OSI model. The OSI model is nothing but open system interconnection. This is the second. This has many layers, 7 different layers, which can interact with each other. This OSI model was first introduced in 1984 by the International Organization for Standardization. OSI model outlines what needs to be done to send data from one computer to another. It does not give in detail how it should be done. The protocol's stacks handle how data is prepared for transmission. The 7 layers in OSI model are physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. The function of layers deals with one aspect of networking. The layer 1, that is physical layer, deals with the communication media. Each layer communicates with the adjacent layers in both directions. Example, the network layer communicates with transport layer and data link layer. Each layer formats the data packet. It adds or deletes the addresses. The upper layers are application layer, presentation layer, session layer, transport layer, network layer. Application layer. It is the workstation or server service in MS Windows in our computer. The purpose of application layer is the user can apply to network service interface. Example, a file can be requested from server and email services. The function of application layer is general network access, flow control, and error recovery. Presentation layer. It formats data for exchange between points of communication. Example, between nodes in a network. The presentation layer function. Protocol conversion, data translation, encryption, character set conversion, expansion of graphics command. Session layer. It oversees a communication session. It is establish, maintain, terminate. It allows applications to maintain an ongoing session. Where is it on my computer? So workstation and server service. Windows client for network. Session layer. Functions. It performs name recognition and related security. Synchronization between sender and receiver. Assignment of time for transmission, that is start time and end time. Transport layer. The purpose of transport layer is repackage proper and efficient delivery of packages. That is, the packages are sent in sequence without duplication and error free. The functions of transport layer are for sending data, it repackages the message to fit into packets. That is, it split long messages and repackage it. The small messages can be assembled and it can be sent. On receiving the data, it performs the reverse, send an acknowledgement to the sender. It solves packet problems during transmission and reception. Provides reliable data recovery. It's the TCP in TCP over IP. It receives information from upper layers and segments it into packets. It provides error detection and error correction. Network layer. The purpose of network layer is to address and route the packets. Example, is if the packet size is large, it splits into small packets. Network layer function. Address messages. Address translation from logical to physical. Routing of data is done based on priority, and routing of data is through the best path at the time of transmission. And congestion control is the main function of network layer. So what is a network address? Network-wide addresses used to transfer data across subnets used by routers for packet forwarding. Example, IP address. So where is it on my computer? So TCP IP software. Next we'll go for the lower layers. Two layers, lower layers, data link layer, physical layer. Data link layer manages the flow of data over the physical media, responsible for error-free transmission over the physical media, assures error-free data transmission to the network layer. The functions of data layer are data link layer are it packages data for transmission over physical line. It packages data for submission to the network layer. It deals with network transmission protocols, that is IEEE 802 protocols, places data and retrieves it from the physical layer and provides error detection capabilities. The subdivision of data link layers are logical link control layer and media access control sublayer. The logical link control layer manages service access points and error and flow control. Media access control sublayer, it applies directly through network card communication. It access control. The logic link control for LANs is concerned with the transmission of a link level protocol data unit between two stations without the necessity of an intermediate switching node. It has two characteristics. It must support the multi-access shared medium nature of the link. It is relieved from some details of link access by the MAC layer. The media access control application is through network interface card driver. This network interface card driver facilitates data transfer from a network software to network card. Physical layer function. It encodes bits into signals. That is, it carries data from the higher layers. It defines the interface to the card. Example is pin count on the connector. So we have seen about the fundamentals of computer networks and the link layer. Thank you.